welcome to Hermes Language Updates video. So, hello everyone. Today I'm going to show you some updates in the Hermes programming language that I'm working on. So I'm just gonna look at the, why isn't the webcam floating? There we go. So I'm gonna start by looking at the Git log here. There are some big things that I have been implementing. I guess we can start with this one. So I have implemented an include function, so you can include other scripts and stuff. So I'm going to show you that. Examples. Include. So basically, let's just write a new script here. Include.he. Let's create a script called functions.he and main.he. Okay, so let's say we declare a function in our functions.he. So I do like void print something, and then I do print something, and then in my other file main.hermes I do what was it? Sorry guys. I do source. I have to look. I don't remember my own implementation. Right. So source x is equal to include functions.he, and then source y is equal to visit x, print something. So now I can use that function print something that exists in this functions.he file. So let's see if that works. So I include that function from the functions.he file, and I do Hermes main, and we get it crashed, but it printed it. Yeah, it has a few bugs right now. I'm gonna have to work on that. I think it's actually because I don't know. Anyway, so that's one thing that I have implemented. Now, if you don't run the visit method is also something that I implemented in this update. So if you don't run the visit method, it's gonna say, oh, it actually worked. I didn't expect that. Oh wait, that actually might be the problem. Yeah, the visit method is probably a little bit broken at the moment. I have to work on that. Anyway, so basically you can include scripts just by doing that. Include functions.he. Cool, right? So that is one thing that has been implemented. Now, another cool thing that I have implemented is compositions. Pretty cool. So let me show you what that is. It's like a functional thing that functional programmers like to do. So for example, I can do remove 1 in x, return x minus 1, int add 3 in x, return x plus 3. And then I can create a reusable composition of these two functions like this. So int my composition, let's just call it my comp, int my comp in x is equal to add 3, or remove 1. And now I can do int result is equal to my comp. Let's put in 12. So what this is going to do is going to just run all of those functions on that one. And I can reuse this composition how many times I want. So, okay, so we're throwing 12 into this. So it's first going to give the add3 method the 12 integer. And it's going to add 3 to that. So we're going to get 12, 13, 14, 15. And then it's going to give the result from that function to that function. So it's going to remove 1, so we're probably going to get 14. Okay, so let's print the result. Might be broken as well, I don't know. Yeah, we got 14. Cool. So yeah, that's compositions, basically. A composition is basically a combination of functions. And you can throw in how many functions you want here. I think you can even do that. Yeah. So yeah, compositions have been implemented. Keep going back here for some reason. And yeah, I have implemented ReadWrite, so you can actually read and write to files now. Let's see if we can do that. So let's say we want to read the README file. We want to get the contents of the README file. Then I would just do object file is equal to open make file. So we said the README file, readme.md. Okay, let's just print the file and see if that works. One argument. All right, we need to specify the mode, so we're just going to do read, and it actually crashes. But yeah, we're getting the object, so print file dot. I think it's file.read. Yeah, so file.read returns the contents of the file, and then we also have implemented like close file. I think that's it. Yeah, but yeah, we're getting a segmentation fault. I have to look at that, but it works. Yeah, so basically I've just been like porting the C file reading methods into the Hermes language. So like you got the fopen function and the fclose and stuff like that. I also implemented the fputs method. Let's see how that was done. I have too many workspaces open. Put. Yeah. So here you can see I'm opening my file.txt with write plus fputs. I put the line hello world into it. So if I run that Hermes examples fputs, it's gonna crash, but it works. So cat my file.txt, it wrote the hello world into there. So that works. I have to look at why things are crashing. Unfortunately, it's the master branch that is doing this, so that's kind of embarrassing actually. Oh yeah, and I also implemented comments. That we didn't have that before. So now you can actually do like let's just write something crazy in here. While x less than 10. Oh, come on. Oh, now I remember I also implemented a really cool way to iterate lists and iterables. I'm gonna show you that later. Let's just see if that runs. Cool. So yeah, we're gonna show you comments. So you can do comments now. This is a loop. You can also put comments like this, printing, and there's also these sort of comments. hello. Cool. And this means that you can also do like things like so now if I put executable permissions on the Hermes script, that one, I can actually now just do /main.he and it will run it because it looks up this shebang thing. Cool, so that was comments. What more did I do? Oh yeah, I implemented a free method, which also is kind of buggy right now, I think. So I can do like nx is equal to print x, nothing weird going on there. What? Oh, I removed the shebang. Nothing weird going on there. And then I can do free. I wonder if that's gonna crash actually. Might no. And now if I try and print the x, it doesn't exist anymore. Undefined variable. Cool. So what more did we do? Right. So now you can access chars within strings. So you can do like string name is equal to hello, and I can do print name 0 to print the first char. This didn't work before, but now it works. Also, I think I implemented a name.length, like a string.length variable. Yeah, so now you can get the length of strings as well. It's pretty useful. All right, and you can also define functions on objects now. So you can do, oh my god, what am I doing? So you can do like object person is equal to, and then I can do void say something, print and then I can do person dot say something. That also didn't work before, but now that works. Awesome. Now I'm going to show you the cool iterable thing that I did. So let's say I have a list like this. List favorite numbers is equal to 4, 8, 16, 24, 32, 42, 48, 64. Okay, and then I can do like void number iterator int n print n. Here's the cool thing that I implemented. It's an iterate statement. So you can do iterate favorite numbers with number iterator. There we go. No while loop or anything needed to iterate these numbers. This is all you need, this line here. Iterate favorite numbers with number iterator. Okay, so let's run that. Huh! Cool, huh? So that's pretty useful. So you can do that with strings as well. So let's do a string iterator here. So like void string iterator char c print c. Let's do string name is equal to John Doe, and then we're going to do iterate name with string iterator. Look at that. That's awesome. So that was everything, I think. I've also been working on another thing. I don't know if I have the mental capacity to tell you about it. Let me see if I can remember what it was before. might be in the README actually. Right, so this is if we do this include thing, I have implemented a way to dump that AST tree to the disk. So let me show you that. So if I do, let's remove this, and if I do source v is equal to include functions.he. Remember we had the print something method in there. I'm just gonna call it so print something just to see if it works. Yeah, cool. So now what I have implemented is this function, write AST to disk v. I think that's all you need to do. Right, and I have to name it something. So let's do functions. Now if I run this, it crashes, but it actually, yeah, it still worked. Yeah, so I have to fix these crashes, but yeah, that's very embarrassing. But it worked, so it created this functions.dat file here. So if that's actually like that's a binary file, and the reason I implemented this is because now I can do like bytecode cache and stuff to make things faster. So for example, in the future, you're actually going to be able to execute this file directly using Hermes. And here's the cool thing about that. If I manage to get that working, I haven't managed to get that working yet, but if I manage to when I manage to get that working, that means that the interpreter is gonna be able to skip the lexing and the parsing stages if you run a dat file, because this file here is already lexed and parsed. It's ready to be evaluated, you know. So if I manage to get that working, we can just skip the lexing and the parsing and just jump straight to the runtime. So for example, I can write a program, dump that AST tree to disk, and I can send that DAT file that was generated to a friend of mine, and he will be able to execute it a little bit faster than he would if he got the actual source code. Yeah, so that's a kind of cool thing that I'm working on. But as you can see, there are a bunch of problems right now with things are crashing and stuff. That's very embarrassing. I wonder what that is actually. Oh yeah, it's the okay. Classic. Oh well, don't worry about it. I'm on it. It's not a difficult problem for me to solve. It's like a memory deallocation issue. So, anyways, yeah. So this is probably the favorite thing, my favorite thing that I have implemented this time. It's this iterate thing. That's pretty cool, actually. So anyway. Thank you guys for watching this video, and I'll hope I see you in the next video. And if you're not already a subscriber, don't forget to hit the subscribe button. And if you don't want to miss any of my videos, also press the bell button. And I'll see you next time. Have a wonderful evening, or day, or morning, or whatever time it is where you are right now. Thank you.